Hey everyone, in this video we're going to do an example of a hypothesis test for two means where you have paired data, okay, or matched pairs. So this is an example from Connect Math here from 11.3. Okay, so we are comparing scales in an experiment to determine whether there is a systematic difference between the weights obtained between two scales. 10 rock specimens were weighed in grams on each scale, and the following data were obtained. Okay, so we have a table here. We got the weight on scale 1 and then the weight on scale 2 and these 10 different rocks. Okay, and this is hypothesis testing question. So we're going to sort of do the steps here. We're going to do each of those steps, identify the claims, okay, get the sample data and the p-value, and then form a conclusion. All right, so right now, we want to state the null hypothesis and the alternative hypotheses, okay? So here we have that mu1 represents the mean weight on scale 1, and then mu d is the difference, okay? So mu d is the mean difference, which is also the same thing as the difference of the means, okay? Can you conclude that the mean weight on scale 1 is less than the mean weight on scale 2? We want to use a 5% level of significance. Okay, we don't need a calculator. Okay, we can just use StatCrunch. Okay, so let's get started here. Remember that the null hypothesis is exactly when the difference is 0, when there's no difference. Okay, so that's just mu. Okay, so let's see, mu d. Okay, so equals 0. Okay, and you want to be careful when you write this. You don't want to get the subscript messed up here. So make sure that this here is the same size as the font here. Okay, and then the alternative hypothesis. Well, we got to think for a second. The alternative hypothesis, we care about when the mean weight on scale 1 is less than the mean weight on scale 2. So we want mu1 to be less than mu2. Okay, so you want mu1 to be less than mu2, but that's the same thing as just having mu d is less than 0. Okay, and this is going to be a one-tailed test, in particular a left-tailed test. Okay, so think about that for a second, make sure that works out okay. Okay, now we want to get the p-value. Okay, so to get the p-value, what we need to do is we don't need a calculator. We can just use StatCrunch. Okay, so what we can do is we need to get this data into StatCrunch, and there's a number of ways you can do this. One way is that you can just enter this in manually. Okay, and if you're a little bit more patient, you could also try using the send to Excel option. Okay, so I'm on a Chromebook here, and when you do that, you get a nice spreadsheet of the data here, and then what you can do is you copy. So copy. Okay, now I'll go to StatCrunch. I'm going to paste it, and hopefully everything gets pasted over. Great. Okay, and there's one of two things you could do. The quickest way is to just go to stats, because it's a hypothesis test about means. Then we're going to jump down to paired. Okay, that's the easier way of doing this. Okay, and we're just going to take sample 1 in the first column and sample 2 in the second column. Okay, and then we're just going to make sure that everything is set here. I want a less than here because that was what was in the alternative hypothesis, and I'll compute. Okay, and here we go. Here's our readout here. Okay, make sure everything looks correct. This is our p-value here, so 0.2933. Okay, so 0.2933. Let's go back to the Connect Math here. Okay, okay, 0.2933. Woohoo! Okay, so we got the p-value. Okay, so that's one way you can get the p-value really quickly. The other way you can get the p-value is where you find the differences, okay, of each individual thing, and then you do a one sample hypothesis test on the mean difference. Okay, but this is much faster. Okay, now we have to determine whether to reject the null hypothesis. Okay, so if the null is true, okay, if the null hypothesis is true, what's the probability of seeing this data here? What's the probability of seeing these individual differences? Well, that's a 29% 0.33%, we are using a 5% significance level. Okay, so since the p-value is higher than alpha, we are going to not reject, okay, the null hypothesis. Okay, so do not reject the null hypothesis. All right. Okay, great. Okay, now we have to state a conclusion. Okay, so is there or is there not enough evidence to reject the null hypothesis? Okay, well, let's take a look at the slides. Here, so we see that if the p-value is bigger than alpha, we do not reject the null hypothesis. So, and there's not sufficient evidence to support the alternative hypothesis, which is the claim that the two means are different. Okay, so maybe the means are the same. Okay, so let's go back to the Connect math here, and let's just fill that out. Okay, so there is not enough evidence. Okay. Yay. Okay, so that's it. Okay, so really this is very similar to just hypothesis testing that we're doing. It's just that now we have paired samples. Okay, so on StatCrunch, what we need to do, we end up just needing to do t-stats, okay? But now it's two samples, but they're paired, so it's a dependent sample, so we use this button here. Okay, that's it for now. Let me know if there's any questions, and I hope this helps.